more trials and tribulations. I'm trying to get this tuner off, and these three wires at the bottom, we're not talking about the grounding straps. The grounding straps are down in here. They've already been removed. Let me see if I can get a light down in there for you to see. The grounding straps are that silver thing down there. There's three of them all the way across. Now I need to remove the other three wires, which are 1, 2, and 3. And they're kind of a little bit difficult to get to, so I'm going to have to remove this bracket that holds the tuner to the chassis. The tuner is out. I had to struggle with that a little bit. I could not get that screw out right there, so I had to kind of twist it and bend it and get in there, fit in there with my soldering iron to get these three wires unsoldered from the bottom. These are the three ground wires I was telling you about earlier. They're just almost like solder wick. You know, they're woven straps, little tiny thin copper woven straps. And these are just three wires that I will replace. When I get ready to put this back in, I will solder new wires to let me see, let me get this thing positioned where you can see it better. I will solder new wires to these three things on the bottom, and I will drop them down through the holes, disconnect the other end of these wires, and solder the new, nice new black wires that I'll attach to the tuner in place where these are now soldered. Got a lot of woolly boogers in there, quite a bit, a little bit of rust underneath there, which was expected. Next thing to remove is the power transformer. You'll recall from the first video, I believe it was, that I had used taken some wire out of my bench and wired this transformer in place because it was just flopping all over the place, and it's time to get rid of it. I'll remove it from both sides, and then this thing will be flopping loose once again, but this time it'll be under my total control. Alright, the power transformer's out. The tuner is off. Look at what I've done. Oh my god, I got everything labeled, I think. I got it all labeled. All I did was clip it off right at the socket pins, because I would have to strip it back and make new ends on it anyway, and this is a good chance for me to inspect all these wires, and as you can see, we've got some pretty frayed looking crap right here. So this will be a chance to splice on some new wires, get rid of some of this old crap like this. This is when you want to do it, when the transformer's out. And for those of you who've never seen inside, the screws were missing from this. It was just laying over to the side. That's what they look like underneath the clam shell is what they call this, the outer shell. There's one on the bottom, one on the top. And it looks exactly the same on the other side, except the wires come out the other side. Let me see if I can open it up here a little bit, let you see what it looks like if you've never seen the side one. Same thing, only the wires come out from between the windings, from between these layers of windings. They just stick out here, there, and everywhere at different points. So what I've got to do now is go to my favorite hardware store, find some screws that'll go down through here, one on each side, to get this thing back together. Okay, it's time to get this can back on here and get that wire soldered on for the grid cap. And you'll notice that this right here, I hope you can see it, it's loose. There's a pole that goes up through the center that holds all this stuff on. And it's independent from the wiring, except that it holds it, it just supports it, that's all. And right here, this thing here, this top thing is very loose against that pole. So what I'm going to do is take some super glue. Now they have it in these really neat little Loctite has them in these little dispensers where you take the lid off and then you just squeeze these two things on each side and it just squirts it right out. And I'll tell you what, it's never clogged. It just works great. I'm going to stick it right down there and put a couple of squirts on there and cement that thing in place. Then I'm going to take some liquid tape. I have this liquid tape. I use it all the time. It's really great stuff. I'm going to take a little bit and put it, let me get a pointer here where I can have something to point with. I'm always prepared, as you can see. I'm going to take some of this liquid tape out of there, and I'm going to put it around, all the way around this area right here on this wire, and this area right here on this wire. And that'll insulate that real good. I just don't like the looks of that. It's probably fine, but I just don't like the looks of it. The super glue went in there, and boy, I'll tell you what, she's solid as a rock on top there. And I put the liquid tape down here on the two wires. Looking real good now. Everything's looking real fine. So what I'm going to do now is solder this new wire on that goes to the grid cap. And then we're going to go ahead and set the can back on. You'll see a major difference when we do. That's it. We have the wire soldered on, and I also, anytime you solder a wire onto an IF can, make sure you check the continuity between the end of the wire with your multimeter to the outside of the case. You don't want any shorts there at all. I have checked it, and it is fine. And I also took the brasso to this can and temporarily put a couple of nuts up there. I'm going to, like I said, stop by and pick up some at my local hardware store that do a better job of matching. But that can is now solid. It's not wiggling all around. It's not loose on the inside when I wiggle the wire. Later on, I'll put the grid cap connector on, which will be like this one here. And that's the first thing we have restored on this radio. I hope you enjoyed it. But that's not it with the IF can that we just fixed. We put it all back together. We found out there's no continuity between the grid cap wire and the can, but I may have messed up something in the coil or the wiring inside the can while I was fiddle farting around with it. So I have to go through and double check the continuity on the primary and secondary, which I have just completed, and it's still good. Before I wrap up this video, I want to do something I've been meaning to do for quite a while. You know, a lot of folks contact me and say, you know, geez, I really want to do these things. I'd like to buy these radios and maybe work on them, but I'm just, you know, they just look so complicated to me. They're just, I just don't know where to start, or you know, I just don't want to mess these radios up, you know. Wait a minute. Stop. Don't let these radios, these old vintage radios, intimidate you. If you can work a computer, if you can get on the internet and find YouTube and find my videos or anyone else's videos, if you can do that, you can fix one of these radios. It's not that complicated. Don't let it intimidate you. Let's just take one little thing right here. Here is an orange, here's what they call a dog bone resistor. Yeah, it looks like a little dog bone. It's got an orange, normally you have a body color, an end color, and a dot. Body, end, dot, B-E-D. Well, in this case, everything's one color. So what that means is the body is orange, the end is orange, and the dot is yellow. So that comes out to 330,000 ohms. So, is that good or bad? And you notice that one end of it goes to a capacitor, and that capacitor hooks to one side of the volume control. Very simple little resistor, capacitor, and a volume control. Anybody can see that. Not intimidating. No big deal. So now, where is it on the schematic? Well, we know it's hooked to one side of the volume control. Well, let's find the volume control and see if we can't find a capacitor that goes down, and one end, the opposite end of it from the volume control, hooks to a 330,000 ohm resistor. Now we come over here, get the lamp down. I hope my camera is good enough for you to see this. Here's the volume control right here. Let me get it up here where we can look at it a little bit better. It'll be a little crooked, but we might be able to see better. There's the volume control right there. And you can see that one end of the volume control hooks to ground. There's the ground symbol right there. Well, that's not the end we want. We want the end that hooks to a capacitor, which is right here. Goes to a capacitor right here. It comes up to a 50,000 ohm resistor. Nope, that's not it. Comes over to a capacitor. Nope, that's not it. We're still looking for that 330,000 ohm resistor. 50,000 and a capacitor is not it. So let's go the other way. We come across here and there it is right there. A resistor to ground, 330,000 ohms. Right there's your orange resistor on the schematic. Nothing to it. So what we're going to do now, I'll shut off the camera. I'll hook up my multimeter. And let's check that resistor out and see if it actually is 330,000 ohms or 330K. I've got the old multimeter set up on the 2 megohm scale, or 2 million ohm scale, because the one down below says it only goes up to 200,000, and we're looking for 330,000, so that exceeds that scale, so we'll have to go up to the next one. Alright, we're on the 2 million scale, and I've taken a black alligator wire, little alligator, it looks like an alligator, and I'm going to hook it to one side of that orange resistor, and I've got the other end of that wire, by the way, hooked to the, for the purposes of showing you, I hooked them to the multimeter probe. Okay, the red one is hooked to the red multimeter probe, and now we're going to hook it on this lead coming out of this capacitor. It's the easiest place to hook it. Let me get the light over here so you can see exactly what we're doing. I'm going to go ahead and hook that baby right there. Kaboom! There you are. I now have the resistor connected to the multimeter, and I should get somewhere around 330,000 ohms if this resistor is any good. Now I do have a 10 or 20% tolerance. Let's see what we got. 346,000 ohms. Right in the old ballpark. That's fantastic. We're going to leave that resistor in there. Good job on that one, Philco. Alright, now had that thing been like really high, mostly they go high, had that thing been up around 500,000, 560,000, way beyond the 10 or 20% tolerance, whichever you prefer. Some people say, no, if it's 10% tolerance, I get it out of there. Other people say, you got 20%, as long as it falls within. By tolerance, I mean 20% higher or 20% lower. I've never seen one go lower. When they get older, they go higher. So this one's good to go. We'll go ahead and leave that baby in there. I like that. Alright. I hope that little demo kind of helped a little bit. Don't be intimidated by these things. They're not that complicated. Anybody can follow a schematic. Anybody can follow a schematic. I always sort of looked at it as a highway system. You got highways running north and south. You got highways running east and west. And where they meet was just a junction in the road, where you turn left or right, and sometimes you come to a T in the junction where you go left or right, and sometimes you can cross right on over. Streets and avenues, however you want to look at it.